Good afternoon, everybody. Welcome to Tibbetts Physics. What is crappin'? I hope you found the first two videos on projectile motion useful. Right now we're going to put them together by launching a projectile at an angle. So let's read the problem. Halloween has ended, so you decide to smash your pumpkin by kicking it with a velocity of 50 meters per second at an angle of 20 degrees. How high did the pumpkin go? How long was it in the air for? And how far did it go? So let's sketch a quick picture. So we kick the pumpkin with a velocity of 50 meters per second. And the angle relative to the ground is 20 degrees. So theta is 20 degrees. Now, when we analyze these problems, we're going to analyze the first part of using vertical motion, which is exactly the same as throwing something straight up and down. But before we do that, we have to find the vertical velocity. So that would be Vyi. We have a triangle, so we're going to use right triangle trig. Vyi is equal to V sine theta. Now, you don't have to memorize this if you're in Regents Physics, because it's right in your reference table. AY is A sine theta, where A stands for any vector. In this case, it's velocity. So let's plug in our values. We've got 50 meters per second times a sine of 20 degrees. Put that in our calculator, and we get 17 meters per second. Once we find this, the initial velocity in the y direction, we're only going to use this number for our vertical motion. We're not going to look at the 50 meters per second until we look at horizontal. Okay, so now we're going to analyze this just like the first video where a ball went straight up and straight down. We know that Vyi is 17 meters per second. The velocity at the top is 0 meters per second. And we know acceleration is g, which is negative 9.81 meters per second squared. And we're going to use the exact same formula we did in the first video to find the maximum height. Vf squared equals Vi squared plus 2AD, where right now Vf is the velocity at the top. So, part A, how high did it go? Vf squared equals Vi squared plus 2AD. Get d by itself. We know Vf is 0, so we have negative Vi squared over 2a equals d. Plug in our values, negative 17 meters per second squared. Squared goes on the outside of the parentheses. Divided by 2 times 9.81 meters per second squared. We plug that in a calculator and we get a height of 15 meters. So that means we went 15 meters high. We'll call it dy. Okay, part 2, or letter B. Find the time it was in the air for. So again, this is just like the first problem we did, or the first video, where we threw something straight up in the air and it came right down. We know the velocity at the top is 0, and we know the initial velocity, so we're going to use Vf equals Vi plus At. But that doesn't give us a time in the air, it gives us the time to the top. Vf equals Vi plus At. Again, Vf is 0. Get t by itself, so t is negative Vi over A. Plug in chug, negative 17 meters per second over negative 9.81 meters per second squared. And we get approximately 1.7 seconds. But to find the total time, the ball goes up for 1.7 seconds, the ball goes down for 1.7 seconds. So the total time is just double t top. Which is 2 times 1.7 seconds, which gives us 3.4 seconds. Okay, so now we've analyzed everything in the vertical motion. We looked at how high did it go, letter A, and how long is it in the air for. So what we're going to do next is we're going to go to horizontal motion, and this is like throwing something off a cliff or a building to figure out how far it went. So we have to look back at what the horizontal velocity is. Just like the vertical velocity, it's launched at an angle, so we have to find the horizontal aspect of it, which is Vx equals V cosine theta. Vx equals V cosine theta. So velocity is 50 meters per second times the cosine of 20 degrees. Put that in our calculators and we get Vx is 47 meters per second. Okay, but we're still trying to find how far it went. So we know the velocity in the x direction is 47. We also know Vx is constant, so it does not accelerate. And we also found the time is 3.4 seconds. So knowing velocity and time, we can use Vx as distance in the x direction over time. So get d by itself. Dx is velocity in the x direction times time. Dx is 47 meters per second times 3.4 seconds. And we plug this in our calculator one last time, and we get about 160 meters. So remember, when you're solving this problem, or any problem when an object is launched at an angle, always do the vertical motion first. Step 1, analyze vertical. And we know in the vertical motion, Vtop is 0 meters per second. And the total time is twice the time to get to the top. And we have to know that the initial vertical velocity, Vyi, is V sine theta. You always want to find that first. And then in the horizontal direction, we know that the Vx is constant, and we find it by Vx equals V cosine theta. And the only formula we use in the horizontal direction is Vx is distance over time, because it does not accelerate. Hopefully you find these videos useful. If you have any questions, feel free to ask. See you next time.